Today, I am like to introduce a new course on implementation of power electronic converter for solar energy application. Power electronic is being used in a large scale for renewable energy conversion in a more efficient manner. It has a great impact on controlling as well as interfacing the renewable energy system both in grid connected and standalone mode. In this course, renewable energy sources, mainly the solar photovoltaic system, with different aspects of their power conversion have been discussed. Some basic principle of their operation with their recent technology and advancement will be analyzed. It is reality that the power electronic plays a vital part on interfacing and that helps to increase the overall performance. Different power electronic converters, topology and their control mechanism will be analyzed in this course. So particularly this course will help you to gather a complete knowledge on designing any power electronic converter and the practical implementation of converter topology. If you have any queries regarding this course, please ask me after the presentation. And all the data provided in this presentation either taken from Government of India Energy Sector web page or from the European Commission Energy Sector web page. Renewable energy sources will constitute a backbone of the sustainable energy system of the future power system, and due to their different characteristics and dependence on climate and geography, they will be scattered throughout the host power system. Moreover, a majority of them must be interfaced with the host grid via a electronic power converter. The sporadic nature of the climate has enforced for major change in electricity generation and consumption process. On that occasion as well, various countries also set a goal of 20% greenhouse gas reduction by 2020. The use of green and renewable energy resources can significantly reduce the harmful CO2 emission. The environmental issues have become significantly important in developed countries. For example, the government of Ontario plans a terminate of coal-fired generation and replace it with a green, clean energy. According to a report in 2020, 2005 for that government, the health related damages for due to the coal plant could exceed $3 billion in a year. Among all the renewable energy sources, more promising and more efficient seems to be photovoltaic energy. Consequently, the installation of PV plants have been developed, particularly in last few years all over the world. The European Commission fixed a motivated goal that 20% of primary energy should be generated by using renewable energy sources by 2020 and 27% by 2030. And these targets need to be implemented in all member countries of European Commission. Along with this, India government has also taken a project that all the primary power plants should generate 10% of their all primary coal power plant should generate 10% of their total capacity from renewable energy sources. According to the last report from International Energy, the total installed photovoltaic capacity in the world exceeds 650 gigawatt at the end of the year 2020. The advantage of using multiple renewable energy sources like PV, hydro, PV, wind are the seasonal and diurnal balancing properties in relation to each other. This system is called usually a hybrid system, has a huge advantage of climate. So if we collaborate these two things, just like PV and hydro or PV and wind, we can take advantage of the climate. If we look the aspect of Indian scenario, the country's total solar installed capacity reached to 37.627 gigawatt as of 31st March 2020. Compared to other renewable energy sources share, the solar energy is little bit high. As we know, the climate in India is totally appropriate for the installation of solar plant, and that's the reason India has the lowest capital cost per megawatt generation power generation compared to any other countries in the world. According to the calculation provided by the researcher, any solar plant installed in India can get profit from the ninth year of the installation. Just to give a note on this, whereas the life cycle of the PV plant is usually 25 to 30 years. So you can get profit from the 10th year onwards. Keeping these figures in mind, the India government has an initial target of 100 gigawatt of solar energy production, including 40 gigawatt from rooftop solar by 2022, and which will ensure an investment of 100 billion US dollar. International Solar Alliances, the organization who decide different standard for solar power plant installation, has the headquarter in India, and they have put forward the concept of one sun, one world, one grid, which defines the more power generation from the sun throughout the world and feed it to the grid. As you can see in the picture, throughout our country, the solar radiation rate is really very high compared to any other countries in Europe or in any other part of the world. So, which can reflect the perfect base of the solar power installation. Now, solar energy is more accessible and affordable for individual users. It encourages changes in the way it is produced and distributed. In 2020, the sector is predicted to focus on artificial intelligence, blockchain-based solution, energy distribution, increased security, and political influences. Artificial intelligence help energy providers and consumers to regulate the reduce of energy waste by controlling data and optimizing energy consumption. That's called the demand response. Despite of consumption management, artificial intelligence can also prevent emergencies and provide disaster management as well. Advanced devices like smart meters and energy collector are built in a way to record changes in meteorological condition and different temperature. It facilitates the anticipation of emergencies and can automatically adjust its settings so that the energy waste should be minimum. Equipment automation expedites the maintenance process and reduce the needs of human work power. Blockchain interface is built to eliminate the middleman. It doesn't only make renewable energy cheaper and more accessible, but can also allow individual households to control their energy consumption without overpaying for public service. Although the blockchain's technology is associated with the financial sector, it can improve information sharing and smart devices utilization and make it more secure, which also leads to improve the building management system. So basically the blockchain interfacing, proper implementation of solar with the board or any artificial intelligent devices. New generation distributed energy sources such as solar panels or wind energy generators can be used in private household and help consumers to gain more control over their energy uses. These devices means the solar panels can be installed in houses and even in apartment buildings. Therefore, the users can generate as much as energy they want and sell it to the energy suppliers and sell the residual energy to the energy suppliers. That means that that called the feed in to the grid. So as you know, the most of the countries don't have any feed-in tariff. In last 2 3 years, few countries like one part in US, Canada, and Switzerland and Denmark, these sector introduce a feed-in tariff for the energy. That means if you produce your own energy, let's suppose you have a rooftop solar and your solar energy accessibility increase the grid parity, and that also increase the grid parity because as more private household can install private energy generator, it becomes cheaper. In recent future, the market is going to see a changes in the prices, which means the solar or the renewable any other renewable energy will become more affordable than traditional energy such as coal or gas. Technologies like artificial intelligence, internet of things, blockchain have a lot to do with making solar energy more user friendly and bringing energy generation and consumption to a more individual level. Climate change is not a personal matter anymore. It's a global threat. that has to be taken seriously. Therefore, government around the world are joining forces to alleviate the after effects of climate change and push environmental policies. What we can see in near future that the most elections, the country elections, particularly in developed countries, will be influenced based on the promises to tackle climate change. On that example, I can give you an example that such effort can be seen for the recent election in Sweden and Norway, where one of the most deciding factor was policies for the green environment. Solar energy is very intermittent in nature. This means that solar panels produce power when the sun is shining and not when it is not. Energy storage allows the solar system to supply power during the night time or in cloudy weather, and that helps to expand the capability of solar energy system. Two main types of solar batteries are basically the lead acid batteries like you have in your car and the lithium ion batteries. The lithium ion batteries is far more advanced and longer lasting and require less maintenance. Not surprising that the lithium ion batteries have a higher upfront cost, but the price has been decreasing significantly in recent years. The cost of the lithium-ion batteries fall to 35% from the first half of 2018 and 76% since 2012. You can imagine how the cost is decreasing day by day for the lithium ion batteries, and that helps the solar plants to generate energy in with less cost. Similarly, the efficiency of the solar cell is increased a lot due to high quality of research that helps to reduce the cost of solar panels. Sometime in developing country like India, government provides subsidies to increase the solar plants that reduce the initial capital investment. Surprisingly, electricity demand in most advanced countries has leveled or even decreased in recent years. What does it mean? That means that if you are generating your own energy, then definitely the energy requirement to the grid will be very less, but generating your energy, but the load to the main grid will be less. So that's why more installation of solar energy will decrease the load on the grid. However, the global electric vehicle sale are expected to reach 11 million units in 2020. I really surprised how that is possible due to this coronavirus pandemic. I don't know the figure can be achieved or not, but definitely that surged to 97 million vehicle in 2025, and these vehicles require electricity to power them. According to the National Renewable Energy Labs (NREL), electric vehicles could cause a 38% increase in US electricity market. As this example is taken from US electricity market, as they have the most electric vehicle right now in the market. And increase in peak energy demand will create a shift in the energy market, boosting the demand from new power generation. Renewable energy sources like solar may help to meet the demand. Roadside charging station provided by the solar cells becoming a new trend nowadays. Now, if you look at the picture here, this is a map of US, and here with a black balls, some number are pointing. That number are basically the payback time where you can get your initial investment back. After that, you can get the profit. So in US, you can see the payback time is from 7 to 15 years. As I told you already, the life cycle of a solar plant is basically 25 to 30 years. So you can imagine how much profit you are going to get after this. What's our objective right now? Let's come to a little bit technical. Uh, Electrification of remote and rural area has been always a major challenge due to the variety of constraints like area accessibility and economic factors. So let's suppose in very rural area that's not possible to sometime to power the total village or power some apartment from the main electricity grid. So in that case you need to install their own power, and that's more economical, and that's why we need the help of renewable energy sources or some diesel generator or some battery backup. We need that. The electricity demand in this area can be supplied with the help of renewable energy sources in an islanded scheme. Usually when the large grid power is not available, the system operates in standalone mode called the islanded system. So for the implementation purpose, we have to focus on two modes. Firstly, on the grid connected modes where the large grid power is available, and another one is the standalone mode where the large grid power is not available. As I told you already that the solar energy is very intermittent in nature, so to stabilize the voltage and frequency you need a BESS, that's the battery energy storage system. So for the BESS and this solar energy, they are all generating the DC power. So we need a DC to AC converter, that's the inverter. So for here, so what we can see, the implementation of solar panel, and either it should be grid connected or it should be standalone. The interfacing system is the power electronic converter. So we need to have a look on the converters, DC to DC converters and the inverters. So for the DC to DC converters, let's come back to the again to the battery energy storage system. If I come back to the battery energy storage system, that's once it is discharged, again it has to be charged. So we need a bidirectional converter. So different converters, DC to DC converters and DC to DC bidirectional converters we have to study. So these are our main objective, how to implement those things, and we will learn everything in this course. So keeping all this in mind, we'll focus on what are the current technologies are used to provide a stable clean power from photovoltaic cell. First, I will come to the solar panel. The solar efficiency increased to 35% from the 90%. Research are going on, and I hope that more efficiency or the efficiency of the solar panel will increase, and that will reduce the cost of solar power generation. Gallium arsenide solar cells are the latest one to use it. The improvement of power converter is another challenge that, as we know, the power electronic converters are improving, the power electronic devices are improving day by day. A lot of research are going on that, and as well as different converters. Just like initially what was that, to get a particular voltage level we need to connect a boost converter, we need to boost the voltage. After boost converter we need to connect the inverter to connect it with the grid. So nowadays the single stage connection where the elimination of boost converter, and sometimes if we require lot of reducing in implementation techniques, reducing a lot of effort on easy implementation technique has been done. And basically for that purpose, jet source inverter, matrix converters, multi-level converters, lot of research has been done on this area, and everyone is looking on easy implementation technique, how to implement those things very easily. Basically these for implementation purpose, what we require two stages, that is the power stage where the main power converter is there, and we need to provide a proper control mechanism, and that control mechanism can be done by using any kind of microcontroller, and that's the most important thing. But before that, that's the proper practical implementation. Before that we need to test those things. So how we can test those, lot of real-time simulator like OPLRT, Plexim, RTDS are there to test it before proper implementation. To test that we need to verify those simulation model in real time. Some other day I will talk about that real-time simulator, that OPLRT, Plexim or RTDS, something like that. What are the technical content we are going to learn from this course? So basically, we are going to learn how the solar energy is working, how the solar panel is working, how the maximum power we can extract from the solar, how after getting that, that's a DC power, how after getting that we need to reach a certain voltage level, and for that we need a DC to DC converter. And the DC to DC converter, how to implement the different DC to DC converter are there, epic converter, boost converter, buck converter, and a lot of other converters are there. We need to know all these converters, and we will simulate in this course these converters in MATLAB, using MATLAB. And basically that can be done in two mode, that is open loop and in closed loop. Definitely when we are going to implement that, we have to implement it the closed loop. So for implementation purpose, what we need to do, we need to design a proper control mechanism. So for control mechanism that will be implemented in any microcontroller, so that microcontroller mechanism can be designed in LabVIEW or Code Composer Studio CCS. So we will learn little bit on LabVIEW, so how to implement that control mechanism in LabVIEW or in Code Composer Studio. So after DC to DC converter, that DC power should be converted in AC for any household use or connection to the grid. So for that we need we need the inverter. So as well as the with the DC to DC converter, we will learn the implementation of inverters, and we will learn the control mechanism of inverters and their implementation in LabVIEW and Code Composer Studio. Now, what are the most exciting thing right now? Finally, we are in the getting into the most exciting slide, and uh, after doing all these things, what different kinds of jobs you can get? That's definitely that will come in your mind. First of all, I want to clarify one most important thing, that is this course will help you to get into two different sectors. Those are education sector for the higher education, and those who are doing basically those who are going to do research in their future, and corporate sector. So what are the things here, what you can get from here? That's research assistant and junior research fellow. And if you are going to continue your research, you need to know how to implement these things, and that will help you a lot to get the research assistant position or junior research fellow position. Or if you are going to corporate sector, that junior assistant electrical engineer, there's the entry level job roles, and your responsibility will be definitely design a power electronic converter, and different power electronic converter, inverter, testing of them, testing of control topologies, how to implement that. And as I told you till now, that solar energy sector is very growing sector right now, and a lot of companies are looking for the assistant electrical engineer, those who have the hands-on experience, how to implement those things, how to implement the control topology, how to check that, how to test the inverters, how to test the converters, and how to test the solar charger, how to implement the battery energy storage system in the solar. So that will help, this course will help you a lot. Now if I look into the senior level job, in senior level job, definitely you need some experience on it. How this course will help you, I can tell you. In senior level, basically the job responsibility for the senior power electronics engineer is the to design a innovative inverter topologies, converter topologies, and the hands-on test and development of embedded hardware. So basically here what you are going to do, that if you know the basics, how to implement those things, how to implement the control topology, you can easily test it in any in any real-time simulator, and design the PCB for the converter or of the inverter. So digital control on hands-on experience on the hardware in loop system is very easy. If you follow this course, that can be done easily. Now, what are the key companies right now? If you look in India, Luminous, Tata Power, Microtech, SMA, Sucam, Solis Inverter, Huawei, ABB, G Power, all are installing solar power plants or rooftop solar right now, or they are producing inverters, converters, everything. And you can, if you have a look on the job portals, you can see a lot of these companies are looking for the entry level engineers, and these are the key companies. In the other side, that's the globally they are famous. There's mentioned few names as like ABB, Plexi, Mitsubishi, on microcontroller MR, and sorry, ST microcontroller, and SMA. We say all they are producing the inverters, and they're looking for engineers. And if you have the hands-on experience, you can put that in your CV. Maybe that will help you to get the job. Now I will come to next slide. That is, what are the basic skills? What are the basic thing experience you require to attend this course? Nothing. First of all, that is you should have the basic knowledge on electrical engineering, how the power things is working, how the power calculation can be done, and most importantly, that is the some knowledge on power electronics, and most importantly on the semiconductor switches. Basic knowledge on MATLAB simulating model, how to develop the MATLAB simulating model is desirable. Otherwise, we will teach you how to do that. And knowledge on microcontroller programming will be, you will be in an advantage situation. You can grab those things very easily if you have.